All right, happy holiday weekend. So that means there's a lot of time for videos. 830 subscribers, getting up there, but I got a lot to go to get my videos matched. But thanks for everyone for subscribing. I will say it does give me motivation to see that number go up. It's when I first started this, I kind of yeah. So that's what I want to say is seeing that number go up really does give me motivation and feel like I'm doing something that's beneficial to the people who watch it. So thank you so much. I'm opening up. Oh, I already, of course, I have it already. I tried to start recording, even though of course I'm already recording. So sound check's good. So what I need to bring up is the book, and I need to bring up VS Studio Code. And I think Jupyter Notebook is already running. I'm actually starting a new use case today. I'm starting use case 4. So I'm gonna need to pull up that notebook eventually. So I might as well just pull it up now and get it ready to go. So let's see if the Jupyter is live. Nope, it looks like Jupyter is down. So let's start it. So we'll get rid of this dead port there and start the Jupyter Notebook. Okay, and then click that up there. Now we're on use case 4, so making a lot of good progress here. We'll probably have to do the same kind of changes to the notebook as before to get it to run locally. As I've said before, I don't recommend anyone watching this who's reading this book do it the way I'm doing it. I recommend keeping it like this and doing it in Google Drive or Google Colab, which you'll have to have an account on Google Drive in order to do, as far as I understand. You get free usage of GPU and TPU compute, so you'll have a much better setup, and you'll be doing it the way the author intends, so you won't have to go through this process of knowing how to change these statements, which requires a bit of expertise to do. So you'll save yourself that trouble in figuring it out as well. But I'm that guy, and I have a nice GPU for gaming. I can do like Witcher 3 in all ultra settings. I have the gear, so I might as well use it, is what I'm thinking. So I have to change that, and then I have to change the import statement here. All right, and then I will restart and clear output, and then we've got unsaved changes, so I will save them, and now it's time to start reading the book. For multiple reasons, we need to know what the network will look like at the certain time in the future, or at a certain time in the future. We want to forecast traffic correctly to plan capacity provisioning in advance. We need to forecast subscribers so we can plan capacity for our IP address pools. We need to forecast user demand to plan capacity in our K8s cluster. Failing to do so will result in service unavailability potentially, not meeting the agreed SLAs, and potentially customer churn. So, how can we have a reasonable prediction of a certain metric of interest so that we can take action now about such future predictions? This is the key pain point we want to solve. In our example, we want to properly plan the capacity of the IP address pools for our BNGs, so we need to have a reasonable estimation of the number of subscribers expected in the upcoming days at different hours of the day. Based on that, if we are successful, then we can have a sound basis to decide how large the IP pools should be and provision them accordingly. Approach. This is and one thing, I don't know if I have had a diagnosis of ADHD when I was a kid, and I have other perhaps related diagnoses still. I have a superpower where I can I can multi-thread my thinking, but multi-threading usually means that each thread is lower in capacity. So when I just read this whole page, even though I was reading it out loud, I was looking at it, I read every word correctly. I was thinking about something else. I was thinking about a activity that I was thinking about going to this morning, but that it starts at 10, so I could go to it late. It costs some money. I kind of want to save money, but it's the last. It's shutting down, so this is like the final time it's going to happen. So I was thinking about that as I was reading this. And as a result, I have no idea what this just said. So I think I'm going to read it again. If I want to go to the activity, I'll just show up late. And I'm going to focus on what this actually was saying. So how can we have a reasonable prediction of a certain metric of interest so that we can take action now about such future predictions? This is the key pain point we want to solve. In our example, we want to properly plan the capacity of our IP address pools. So like, for example, for DHCP, for our BNGs, broadcast network gateways, I think is what that stands for. So we need to have a reasonable estimation of the number of subscribers expected in the upcoming days at different hours of the day. Based on that, if we are successful, then we can have a sound basis to decide how large the IP pools should be and provision them accordingly. And remember, the use case is how many subscribers will be online in my network next week. Approach. This is a time series forecasting problem. We will need to use algorithms that allow us to forecast a metric based on its past history. This is what is called autoregressive algorithms. They effectively are regression algorithms, so you could think they are supervised learning, but the label for the training process is the metric itself, using some portion of the past history as the training data. That is the auto part. In that sense, they are self-supervised algorithms for practical purposes. Time series forecasting might be univariate or multivariate. We could think, and I did it again, but I just did it for. You know what? Let me start again because sorry, my mind is not. You can't tell just from me because I'll read everything right, but it's just that difference between being focused in on what I'm reading and just kind of. You know how you would like bounce your knee or something like that. Like what I can do is have the reading become like bouncing my knee, where like I don't even realize I'm doing it. I have no idea what I'm reading. It's just not. It's just kind of a. It's just kind of a thing that's just not registering in any way. So let me read this again. So approach. This is a time series forecasting problem. We need to use algorithms that allow us to forecast a metric based on its past history. This is what is called autoregressive algorithms. They effectively are regression algorithms, so you could think they are supervised learning, but the label for the training process is the metric itself, using some portion of the past history as the training data. That is the auto part. In that sense, they are self-supervised algorithms for practical purposes. And I have the cure to these attention problems. I've talked about this before on the channel. It's a very expensive drink, like $3 a can. Update Energy. You can get the actual active ingredient, which is a derivative of caffeine, just in capsules form. I've been wanting to try that, but for now I'm happy with this, and I don't use it every day, just kind of when my mind is wandering like it is now. And all right, that should help going forward. Time series forecasting might be univariate or multivariate. I remember reading this. We could think that the forecast of a specific variable in the future really depends on the evolution of other variables and not just on the past of the target variable itself. In our use case, we will consider only a univariate approach. We are going to explore various popular algorithms and approaches. As referred earlier, I have no intention to find the best model, but to show you different options that could be used to solve this problem. More to open your eyes to the spectrum of alternatives rather than try to find the best one. None of the algorithms or models tested in the notebook offer particularly brilliant results in this case, partly because I have not tried to optimize them either. Input data. We have already used in one of the use cases earlier in the BNG underscore subscribers metric. So we used this metric before in one of the earlier use cases. We will use it again in this exercise. The difference is that we will generate it for a different device, PE5. The following is the device metric generation policy we have configured in SANS for this device that will give us an intuition of how this metric will look like once it is generated. So, okay. In exercise 1 for time series anomaly detection, we used PE-4, which had simply a seasonal pattern with certain anomalies introduced. Now for PE-5, we are generating a metric that has a more complex behavior. What the policy indicates is, during 96% of the time, the metric will be somewhere between 5,000 and 5,100 subscribers. It will be generated taking into account daily and weekly seasonality. There will be a trending component that will make the metric grow by 2,000 linearly through a period of 1 month. During 4% of the time, the value will go down somewhere between 500 and 550. This basically simulates an anomalous behavior where, for some reason, the number of subscribers drops significantly. We have generated a complex metric that is seasonal, has a trend, has anomalies, and has also a random component of noise. With the above policy defined in SANS, we will call the data generation method to get the desired metric. Alright, so diving into the code here. So let's advance the bookmark and run it. So we're getting the data frame, defining the data frame. And we can see which cells I've run already. I haven't run any because there's no out information and there's no numbers populated there. All right, so it looks like we got a new, and I forgot something. So let me restart and clear the output. So all this will do is run it in the bash prompt where Jupyter was executed. It will not install it into the Juniper kernel or into the Jupyter kernel itself, and you need it in that kernel. Otherwise, you can't use it in notebooks unless you stop and restart the notebook, as far as I understand. So, but there's an easy solution to that. You just use a magic method by using the percent sign, and now it installs it directly into the kernel. Okay, so it looks like we might have had an update here. No updates, so no need to restart. Now we're installing this one. Okay, so we might need a restart, but we'll deal with that when we get there. To restart the kernel, all you do is go here under kernel and hit restart. Which, you know what, we can do right now because it doesn't. Oh no, all the variables would have lost. So let's save that for later if we need to do it. Okay, so metric df equals sans.generate. Yep, so that's the next one to run. Oh, and okay, so it has no what? Okay, so this is good. This will give people watching this a sense of how I troubleshoot these. I had to do this in the last notebook. I had to troubleshoot and resolve an issue. So I like these errors here because if you're watching this, you can really kind of learn how I think when it comes to troubleshooting these, and that can really, I think there's a lot of value from that. So not that I do everything perfectly, but um, it's food for thought, you know. So uh, data frame object has no attribute append. So so okay, so we can see the so it defined the data frame object. Or no, it's I think it's talking about a different data frame object. So I don't know which data frame object it's talking about, and I don't know which. Oh, we can see it right here. So device inventory equals device inventory dot df for data frame dot append. So it's this device inventory data frame that has no attribute append. So where is that? Where is the device inventory data frame? So it comes as a result of executing some other part of the code. So yeah, it comes as a result of executing this method here for sans. So what you do is the first thing you feed it the start time, the end time, the params. So we did that for sure. And then the first thing it does is it defines device inventory using this function here, which is generate device inventory. And now we can see generate device inventory does a device inventory dot append. So I think it's expecting device inventory to be another data type that does have the append, perhaps something like a list, whichever data type has an append. I think it's expecting it to be, but the current data type does not have that. So let's learn more about this device inventory df. So the main thing we can learn about it is that it comes from so interesting. So I guess what I want to know is where did this come from initially? Because we can see we're redefining it with appending other things to it. But I want to know where it was before we like we can see the df is added on, and initially it's defined without the df, and then it comes through this this function here. So I would like to see more about this function. It looks like it's in sans.py and somewhere around line 60. So let's pull that up. So we're going to code sans.py. All right, and then we're going to go around line 60 or so. All right, and here's the function. So we can see what's going to happen. What's going to happen is it's going to say device inventory equals this, and then it's going to call this function for that we can look at here. So the function returns the function. Does the function return anything? Okay, so yeah, so the function will return device inventory df, and it's trying to do that. It's just it fails doing that because df, because it has to append to the df, but it can't do that. So let's see why that's the case. And remember, it failed around line 60 or so. Yeah, so it's doing it for this chunk here. It's generating core devices. So for I in range, if their inventory, so now it's creating an inventory of junipers, and then we don't know if it does the if or the else. All we know is that here, it's filling the append. So let's take a look at what this could be. Okay, so the first thing it does is it defines it as a data frame here. So let's get some help on that and see what this looks like. So we're gonna do import pandas as PD. Yep, and then we're gonna do a help on pd.data frame. All right, and now we want to see what it's going to return back. So it returns pi capsule. So let's define it. So we're going to say device inventory df equals pd dot data frame, and then we can see device inventory labels. So let's see what this looks like. Okay, so we've just got a list of strings. So let's feed it a list of strings. So the list is going to be this is fake data for T shooting. Okay. Okay, so now we can see if this is appendable or not, or what is going wrong here. So let's do a help on it. All right. So now we have a data frame. So you can't. I don't think you can append to a data frame. I don't see that listed here. So we have here's the method. So we can add to a data frame. We can aggregate all, any, apply, and we're beyond the, if it's in alphabetical order, we're already beyond that. It does not have append. So there's probably some equivalent method we can use to do what the author intended. For example, we could append to the actual list that was fed to the data frame. The way this device inventory labels. Or I think a better way to do it is we can just use the proper method for adding more information to the data frame. We can use a valid method for that rather than append, such as add, I would guess is valid, but we can have in this modern world we live in, which is insane, we can just have a simple conversation with ChatGPT and figure this out. Okay, so I'm doing a exercise for a technical book, and the exercise is to create a pandas data frame and then use a simulator written by the author of the book, and I'm having trouble doing that. So what I'm having trouble with is when I run a function in the simulator, the first thing the function does is it defines a variable by calling another function from the simulator code that the author wrote that returns the definition for that variable. Then what happens is the variable is oh, you know what? Well, anyway, in short, what my question is does a pandas data frame have the ability to dot append? And if it does not, what valid thing could you do instead besides a dot append that would fix the issue?
Pandas data frames do not have an append method in the same way that lists do.
Exactly.
Instead, there's a method called append, but is used differently and is deprecated since Pandas 1.4.0.
Ah.
The recommended way now is to use PD concat to combine data frames.
Okay, so what's happening is the author is using an older version of Pandas, and Pandas did have append, but it was changed to dot concat. So this is what we need to do is just change that append to dot concat, and then we should be good to go. So let's look for every instance of dot append. So we've got 86 instances of that. Yeah, I'm surprised we didn't get this issue before. So I don't know, maybe if my version of Pandas is different, but okay, so this sounds like an easy solution then. All I have to do is find and replace all for the dot append method to dot concat instead.
While the solution is to use PD concat instead of append, directly replacing append with PD concat in your code might require some adjustments. Here's a step-by-step guide to make the transition smoother. Identify the append calls. Locate all instances where append is used in your code. Replace with PD concat. Replace append calls with PD concat while ensuring that the data being concatenated is in the correct format, i.e. data frame or series. Example transition: suppose your original code looks like this. Update code with PD concat is how you can update it. Explanation: convert dictionaries to data frame. When using append, you might be directly appending dictionaries. Convert these dictionaries to data frame first. Concatenate data frames. Use PD concat to combine the original data frame with the new data frame. Function example: I have your code uses a function to append data. Here's an example of how to modify it. Original function, updated function summary. Ensure that the data you are appending is formatted as a data frame.
Okay, so you have to make sure that this, like here, this policy entry. So no, it's not a data frame. Okay. Okay, so no, it's not a data frame. Sometimes it's appending a dictionary, a Python dictionary, instead of a data frame. It sounds like what happened is the author wrote this last year. They wrote it in 2023, probably like near the beginning of 23, or maybe even in 2022, or even later than that, because it takes a while to write a book. So the book was released in 2023. So I think what happened was the author used an older version of they used the most current version of Pandas at the time, but the change that took out append happened so recently that now all the examples in the book are kind of borked, if you know what I mean. They're not working. So I guess the easy solution would be I just downgrade my version of Pandas, right? Yeah, let me do that.
Downgrading your version of Pandas to a version that supports the append method is indeed a valid solution, especially if you want to follow the examples in the book without modifying the code.
Let's do that.
Here's how you can do it. Step-by-step guide to downgrade Pandas to current version. First, check your current version of Pandas to know what you're working with. Uninstall current version. Uninstall the current version of Pandas. Install specific older version. Install the specific version of Pandas that supports the append method. For example, you can install version 1.3.5, which is from late 2021. Verify installation. Verify that the correct version has been installed. Downgrading Pandas here is a summary of the commands to run in your terminal or command prompt. After performing these steps, you should be able to use the append method as described in your book. This approach allows you to follow the book's examples without having to make significant changes to the provided code. Example verification: you can verify by running a small piece of code. This should work correctly with Pandas version 1.3.5. Long-term consideration while downgrading Pandas is a quick fix. It's worth considering that using an older version of library can have implications for future compatibility and access to new features. If you plan to continue learning and working with Pandas, you might eventually want to get comfortable with the latest version.
Okay, yeah, I'm using version 2.2.2, so I think I'd rather just downgrade. So tell me this, does it make sense that the author, there are some typos here, but does it make sense that the author at the time of writing the book might have used the most recent version, or is that version, the last version before append was taken out, really old, and it seems like the author just kind of used an old version because just, for bad reasons. Can I be charitable in this case? I hope I can.
It does make sense that the author might have used the most recent version available at the time of writing the book. The removal of the append
Yeah,
method happened
there we
relatively
go.
recently, and it's entirely plausible that the author was using a version of pandas that was current and stable at that time.
Okay.
Timeline of pandas versions in append method pandas 1.3.5
So
November
that makes
2021.
sense. It was so when you're in the middle of writing a book, I understand, and honestly, you might have even started it in 2021. It takes a long time to write a book, so they might have made it deprecated. Definitely in 2022. He's probably right in the middle of writing it. So they make it deprecated. It's like, oh, I have to rewrite everything. So he probably just, kept doing it. And then, Pandas 2.0 was released in March 2023. This book was released. I think probably around that time. We can figure it out. So if we go to the copyright. Well, the copyright just has the year, but so that's definitely what happened. But there's a very easy fix to that. All we need to do is use a version of Python that supports the .append method. So we can use version 1.4.0. Okay, and now we've got a problem here. Metric df is not defined. That's because I I deleted that cell by accident, and apparently there's no option to undo. Oh, undo delete cells. Oh, okay. Here we go. So undo delete cells. So let's run the cell. There we go. And now all we've got is that warning for all 86 instances in the code that it's deprecated and will be removed, and to use pandas.concat instead. So that's okay. I can live with that. The code's still going to run. All right. So the next one is to do this. And you know what? Let's get rid of that warning. That's annoying. Let's just use a really old version of Pandas, because the author said this is just to demonstrate something quick. It's not meant to be like production solid code, so we don't have to use the latest and greatest and everything. So let's use 1.3.5. All right, and then we'll clean up everything. All right, and now we won't get flooded with those warnings, which will be a lot nicer. And the behaviors of and greater than. Okay, well, shoot. Okay, well, we have to use the version of Pandas that's greater than 1.4 in order for it to be compatible with one of the other packages. But let's just deal with that when we get there. If then we'll just go back to 1.4. Worst case scenario, we'll just change all the appends there to concats, and then that will be an easy solution. So okay, so same problem. 1.4 was working, so let's go back to that. 1.4.0. All we had to deal with was those annoying messages. So we're gonna go back to 1.4.0. Okay, so now we got all these annoying messages. It will be we can just ignore them and move on. And we can get rid of this cell now because we don't need to know the version anymore. The version is 1.4.0. All right, and this might take a while to complete because we're defining a data frame here that could take some time. All right, so still working, still getting really annoying messages that I wish would go away. I know how to get them to go away, but it wouldn't be. It honestly wouldn't be that hard. I think all we'd have to do is change it to concat. But yeah, we're trying to append a dictionary rather than a data frame, so I don't know how that's going to work. Okay, yeah, so I'm downgrading the version of pandas to 1.4.0. I can't downgrade it any less because there's other modules that depend on it being a certain version. So I get all these annoying spamming, warnings that it's going to be deprecated, which I'm okay with, but I feel like it's better just to use, the current version. It's just going to make everything better. So I'd like to do that, and I'd like to swap out the .append for .concat. But as you said, from one of the differences is with .append you can feed it a Python dictionary, but with .concat it has to be defined as a data frame before you can concat it with another data frame, unlike the .append. So it sounds like it's actually got less features than .append. So according to the code, how it's currently written, the .append was used for the .append was already used for, it was used for Python dictionaries. So I guess it's not as simple as just find all and replace all with .concat, correct? Because I have to make sure with the other method, concat, right? Concat, right? Because I have to make sure that the things that are being concat, that those are data frames and not dictionaries. So I have to go through the code, and in addition to find replace all append for concat, I also have to make sure that the dictionaries are data frames before they are fed to concat.
You're correct that simply replacing append with PD. Concat won't be sufficient if your data is in dictionary format.
Right.
You will need to ensure that any dictionaries are first converted to data frames before concatenation.
But I mean, that's not
Here's a
hard.
step-by-step approach to updating your code. Find and replace append. Locate all instances of append in your code. Convert dictionaries to data frames. Before using PD, concat, convert any dictionaries to data frames. Example of updating the code: original code using append, update code using PD. Concat automating the process. If you have multiple instances in your code, you can create a function to handle this transformation. Explanation function to handle appending. The append __ data frame function checks if the input data is a dictionary. If it is, it converts the dictionary to a data frame. Use PD, concat, concatenate the data frame with the new data. Applying the changes, you can systematically replace append with calls to append __ data frame. Original code, updated code. This approach ensures that your dictionaries are correctly converted to data frames before concatenation, maintaining the functionality of the original append method while adapting to the newer pandas version. Example of bulk update: if you have multiple files and want to automate the replacement process, you can use a script to find and replace append with append __ data frame. However, you will need to manually check and ensure that the function is used correctly in each context.
Oh.
Conclusion: by converting dictionaries to data frames before concatenation, you can effectively replace append with PD, concat, ensuring your code works with the latest version of pandas. This approach maintains compatibility and avoids deprecation issues while allowing you to take advantage of new features and improvements in the library.
Do I have to set ignore context to true?
Saying ignore underscore index equals true when using PD. That is typically necessary to ensure that the index is reset in the resulting data frame, especially when you're appending data.
Okay.
If you don't set ignore underscore index equals true, the original indexes of the
All right.
contaminated data frames will be preserved,
So
which can
I
lead to
know how to
unexpected
do
results if
this.
the indexes are not unique or if you want a continuous index. Here's an explanation and example to demonstrate the importance of ignore underscore index equals true. Without ignore underscore index equals true when you don't use ignore underscore index equals true, the indexes from the original data frames are preserved. Output. With ignore underscore index equals true when you use ignore underscore index equals true, the indexes are reset to ensure a continuous index. Output. Summary. Without ignore underscore index equals true, the indexes from the original data frames are preserved, which can cause duplicate or non-continuous indexes. With ignore underscore index equals true, the index is reset, resulting in a continuous index in the final data frame. Updated function here is the updated append underscore to underscore data frame function with ignore underscore index equals true. By using ignore underscore index equals true, you ensure that the indexes in your final data frame are continuous and start from 0, which is generally the desired behavior when appending rows.
Okay, and they use a different formatting than I typically use. I typically have spaces there, but... Alright, I think this is right, isn't it? Or PD dot? Oops. Yeah, that should be it. Okay, so all I have to do is go through and swap these out. Find replace hook, line, and sinker of everything. Yeah, so that's all I have to do. And then okay, so yeah, this is all I have to do, and we can do but the problem is it looks like not all of them are labeled that way. I thought there were 80 matches. Now, if it's underscore DF, then I have to replace it. If it's not, then I don't. So these are not underscore DF, so I probably don't have to replace these. So I don't replace every append, as far as I understand. Well, let's see what event policy is. God dang it. Okay, event policy is a data frame. So yeah, everything with shoot. Oh, that's so annoying. Okay, so I guess I can just get like creative with it. So I can no, because this is a variable for each. Oh man. That's so frustrating. Oh man, that's not good. Well, let's see how the code's still working. Oh, well, the code's finished now, so let's see. Oh, and there we go. Yeah, so we're fine with using that downgraded version. We could upgrade the code. It's probably better to go forward. I kind of wanted to just show how to upgrade the code because I feel like that would be a good learning lesson for the people on this channel who need that lesson. For people who can already do it already, it might be yelling at the screen and a source of stress. But I think this is useful to just show somebody reading Python code. I think that's not showed very often. Somebody who's already comfortable with Python just going in and reading it and making changes to it based on what they're reading. I think that's very rare to see on the internet, so I'm going to do that. So yeah, we can see we have the dot append. So based on our conversation with ChatGPT, we figured out that dot append is deprecated. So now we have append to data frame, which is oh my god. But what we can do actually is go up to our imports and we can do import pandas as PD. We can also do from pandas import append or whatever it was called, append to data frame. Oh, okay. Well, that's interesting. Anyways, let's just do it this way. It doesn't matter to have the PD dot there. Okay, so but now for each of these we have to make sure that it's correct here. Okay, and then we'll do a control find on these. Okay, so we've got 6 entries for that. So we've got to replace all 6 with this. So we'll delete this one. And now we've got only 5 entries, so now we can find and replace the rest of them. There we go. And now let's move to the next one. So we know that basically any dot append is going to need this, so we can search for dot append. But it looks like okay. So we can narrow down our search with that because the ones that replaced will end with underscore. We'll have an underscore there. The ones that aren't replaced will have a open brace. Okay, so here's the next instance of that. So we need to go in and change it. And this shouldn't take too long because we're doing those find replaces. So it seems like it's a lot of work, but it's really not. I can also show in the version control. And you know what? I can actually show how to push this up to my fork as well. And I might want to contribute this back to the original repo because this will help the author out a lot because this will make it so you can use the most recent version of pandas. So this would be doing the author a big solid. So I might consider contributing this back to the original one where it was forked off of. Okay, so now we get rid of that, and it's F equals append to data frame. Oh, and I forget what it looked like. So append to data frame. There we go. So now instead of this dot append, we have this function that takes parameters, and the first parameter is what you want to append to. The second parameter is what you want appended to what you want to append to, and then the next one are optional flags. All right, so let's see how many matches we get on this. We get 6 matches, so let's replace them all. Oops. Okay, so let's get rid of this line. We'll now have 5 matches instead of 6. And let's replace all 5 of those matches. All right, now on to the next one. So we're going to match on dot append there. And we have to be careful not to blow over anything that's like a real dot append for like a list or anything like that. But I think we're good so far. So we've got some more here to get through. And let's make it a bit easier here. We're going to open a new text file like that, and then we're just going to get a template to work with because that will make things easier. So, and it looks like something happened here. It didn't successfully do what we intended. Oh, you know what? It did because it's just this next line here. Yeah, so this is successful. So we can use this for our template for the after. But now we need an example of the before. So we can find one here. Here's the before. There we go. And now we can use a template and go a bit faster because of that. So we're going to replace it here. Then we're going to replace, we're going to add this here. And then replace this here. There we go. And then we'll find every instance of this. So we've got 5 instances of it. Looks similar to before. And then we'll replace every instance of that with this. All right, now no results. So let's go back to .append. Okay, so now on to the next one, and we got to get through every one until until we're all the way through. So this here is kind of what what programmers get paid for. This here is basically what you'll see someone doing at work. If you are actually able to shadow a real software developer. So I'm really glad I'm able to demonstrate this, because I think it's important that people are able to see this. I'm sure you can see this on some sort of YouTube channel, but my experience with YouTube, a lot of time you're just seeing an advertisement. You're seeing people try to sell you, a course or a book, which it's probably not the worst way to make money. I'm actually considering creating like a course or something in the future, because these videos are unwatchable. So I'd want to make something that is more watchable, and then I need to make bread too, just like everyone else. So I am considering that in the future, but in the here and now, I think this is really invaluable to show people, because this is how it's done. This is how the sausage is made. So okay, so let's see how many matches we get for this. We should get about 5, just like for everything else. Okay, so we've got a few more matches here. We've got 11 more than the other ones. Okay, and we've got to be careful to do our replaces correctly. It looks like I did not. Yeah, so it looks like it was missing the last one. So when I replaced it, it wouldn't have replaced it properly. All right, so now we've got our template ready to go, so we can just wholesale replace that line for this line. And now we have no results, so let's go to the next one. All right, so now we're down to making some good progress, and as I said, yep, this is this is what paid software development will probably look like. So it's tedious, it sucks, it's work. And as far as are there the best software developers in the world, do they do it in a different, more optimal way? The answer is probably yes. Are you the best software developer in the world? Do you need to be to work in a job and make a good living? The answer is no. Okay, so there we go. And yep, so keep on going. And honestly, I'm sure this sort of thing is done by the best software engineers in the world. Okay. Okay, now we've got 18 matches. We have to be careful too, because the author's style is to not use these spaces. Okay, so sometimes we're gonna have some matches that aren't gonna work. So we have to be careful to do some debugging once this is complete, to make sure that our changes went through. So we've got 18 here, so 18 are done. So we're getting near the finish line here. Oops, and it looks like I made an unintended change to the file. And we'll see all the changes I made in here, and then we'll do a commit, hopefully to my own and not to the author's, like I messed up before. But maybe I might consider contributing to the author, because that'd be a big win for everyone. You know, you get to use people in the future wouldn't have to deal with this, and then I'd get my name on this book gets a high mark from me so far. All right, so there we go. Yep. So the next step is to do a replace all for this. So we got 4 matches here. All right. And looks like we're very nearly done. Now we do have something here, updated metrics. That is just a plain list. So one of the tells is it doesn't have that extra flag there. So we got to make sure not to replace this one, because what we're doing is the append method on a list. So it kind of makes sense that they're updating that, because when you control effing like this, it's hard to tell whether you're dealing with a data frame or a list. And if you are dealing with a data frame, then you need to be aware of that. Otherwise, you're going to make some mistakes. So we do have one here. You know what? Let's search on. Well, we can't do that because we got to do this one next. All right. Yeah, this is really good. Okay, so only one match for that one. Okay, so we've got 19 more instances of dot append. So let's go through all 19 and make sure that they're for data frames and not lists or any other data object. If they're for data frames, then we will go and replace them. So the big giveaway is this extra flag here. We know it's for a data frame if we see that. All right. All right, and this is yep. So this is for a list, and the giveaway is there. It doesn't have the yep, and it says in the variable name, which really important to use descriptive variable names like this. This underscore df is another giveaway. Now it could be named wrong, but it's this is why it's so important to name your variables correctly, because if it was named wrong, then we'd really be wrong. We really be having trouble, but as it is named correctly. Now it could get tricky, but it says underscore list, so that's good. Yeah, so this is really well written Python code, because we do have the prefix there dot underscore list and underscore df. Even though you could name the variable anything you want, you can see why it's so important to name it something descriptive. Otherwise, we can't tell what sort of method we need to run on it. So it looks like we got at least one more here. So let's fix this one. Okay, and this one's a little bit different. Uh, so now we're going to append to it metric object of the 0th index. So a little bit different there, but pretty much the same. All right. All right, 16 to go. All right, so I think that's it. Everything else is a list. Now we've got updated metrics. I don't know what that could be. Okay, so that's definitely a list. I wish it had underscore list on there, but or whatever. Maybe it's not a list. I think it is, but the giveaway is there's not that flag there. All right, so really happy everyone got to see this. This is basically what a part of what a real software developer paid on the clock would be doing is something this tedious. So okay, so let's run that file. So we're gonna go to cd sans. We're gonna do python sans.py. And there we go. So the file ran successfully. So all those changes went through. Let's restart the Jupyter environment and do one more test here. There we go, and then we'll close the port's already closed, it looks like. So there we go, and then we'll restart the Jupyter environment. There we go, and go to use case 4. Okay, and all the changes are made. So now we're going to get rid of this, and we're going to go with the up-to-date version of Pandas. So restart and clear all. All right, there we go. And running it locally, of course, because I'm that person. So warnings that don't matter, you can ignore those. And here's the moment of truth. Oh, which version am I using? What? Oh, is this not how you do it? Why is that taking so long? I have to do a print on it? I did a print. Why is this taking so long? Oh, because it's waiting for this. Okay, well, let's get rid of it. Okay, that should be it. Yep. So, see what we got now. Hopefully the newest version. And notice how we get no errors for sans. Okay, so we're still using 140. So let's specify the latest version of Pandas. 222. Let's use that. And that's what we were using before. So let's use that again. Okay, now we're 222. So, data frame. Okay, so it looks like I must have missed one here. So, which one did I miss? I missed line 65 in sans.py. So it looks like there's some issue with it didn't pick up on that change. So I'm not sure what's going on there. Yeah, so it has to pick up on that change. Let's do a get status. Oops. And then let's get this back to how it was. There we go. So one of the changes should be in that sans folder. Oh, right, but we have it in the get ignore. So code ignore. But it's taken out. Oh, that's interesting. So why is it not showing up? What? Oh, you know what? It's because I never hit Control S. Oh, man, that's so annoying. Yeah, it's the little stuff like that that gets you. Now, normally there's autosave. I don't know why autosave. Oh, it's not checked. Okay, so I got to check autosave. All right, there we go. So simple problems have simple solutions. So I'll take a simple small problem any day of the week. All right, so now if we start the Jupyter Notebook again. And let's do the test again because we were testing on that unsaved file. So we're going to do Python 3 sans sans.py. And okay, so the test still passes even though it's running on the updated file. Let's do a get status. Now the get stuff won't affect whether the file runs or not. You're just saving. You're just taking a version of it and saving it in get. So you're not even saving it in the place where it will actually run the code. It matters whether or not you save it here, whether or not the symbol shows up here that you haven't saved it. But that's a different place to save it than in get. In get, you're saving the snapshots of the file, the versions of the file as you work on it. But the versions of the file that actually execute by Python are saved elsewhere. So we can see where they're saved. They're saved here. We can see where they're saved in Git. They're saved in this hidden .git folder. So you could dive into that if you want to get really messy, but I recommend to just stick to the basics of Git and try to use it in the most simple, effective way possible because it just gets very complicated. It was written by one of the greatest minds in computer science ever, the guy who invented Linux. All right, so there we go. So now if I do a git status, we've got sans.py. So let's do a git add on that. Okay, and do a get status again. So now this is highlighted in green, so we will commit this, assuming the Jupyter Notebook can use it successfully. So let's try that. Open in browser. use case 4. And then kernel restart and clear all outputs. There we go. Yep, equals 2.2.2. Okay. Run that. There we go. Run this. Run this. All right. So now we're going to print pd dot underscore version just to do a sanity check there. Sanity checks are always good. You should say, yep, there we go. So now here's the moment of truth. So same problem here. Pandas has, okay, so I think ChatGPT hallucinated on me. So I just, wasted a lot of time not verifying that that method actually exists. It would have been really easy to verify that. All you need to do is go to IPython 3, import pandas, and then do dir on pandas. And now we can do a control F on this method. And yep, we get no results here. So so it's concat. Concat is the proper method, not append to data frame. So yeah, and it said that. So all we need to do is swap out this now for concat, I think, and that should do it. Yeah, 70 instances of that. There we go. And you can tell as well it wasn't valid because it didn't highlight in yellow. How do I get my... Where's the squiggly... there's no squiggly mark on this keyboard. I need the squiggly mark. I use that all the time. View terminal. What? Why can't I view? There's no terminal? Oh, there is. Okay, right there. So yeah, so we can see the ones we have. We don't have a vent there. A ChatGPT hallucinated, or I didn't read the output correctly. That's probably more more likely. But concat should work. So let's test that. So we're gonna go to here. We're gonna go Python 3. Sans and then sans.py. All right, runs without any problems. So just for a sanity check, let's stop this and restart it. Probably don't have to do that, but I'll just do it anyway. Right, and then now we'll get to that moment of truth, and hopefully we'll have a better result. So kernel, restart and clear all. All right, and now we're installing pandas. We're installing this other one. We're modifying it to run locally because I'm that kind of person. And then printing out the version. There we go. And the moment of truth. Okay, so concat takes one conditional argument, but two positional arguments were given. So I think concat is not in this sort of syntax. I think you have to have this moved over here. So we can do that. That shouldn't be bad. Now this is really a example of real world paid work. You just do a whole lot of work that you have to undo and then redo. That's what it's all about. All right, but this should be the answer here. So we just got to do that for 70 instances, which is not a lot of instances. If you were in the real world, you might have to deal with 70,000 instances or 70 million instances. In that case, you would need to use some other unique. Typically in code like this, you wouldn't do that, because the best practices for writing code, you're not going to have lines of code with millions in it. So it's it's okay. So this is pretty reflective of what happens in the real world of coding, which is great. That's exactly what I want to show on this channel. Okay, so we're doing this like that. Now I'm surprised when I ran the file it did. Oh, you know what? It's because I'm not calling the functions. So that's why it didn't fail, because I'm not calling the functions. So running the file isn't enough to tell whether these changes are valid or not, because I'm defining the functions but I'm not running them. So the code does not execute until it is run. Now, a really high-level programmer will be able to do this better than I can. They'll probably not use the mouse. They will just use their keyboard only to do this, and they will do it very fast. But I'm kind of a blend of the two. I'm a bit late to the game on software engineering. Don't have a degree or anything. Just kind of came to it from the perspective of network engineering, so you'll have to bear with me. The difference between getting something done in an hour versus 10 minutes, in my opinion, really isn't that much. As long as you get the same amount of work done by the end of the day, it doesn't really matter how long it took you to do each individual part. Oh, and we've got a problem here. We've actually... what? Oh, you know what? Oh, that's not good. So this inventory is not even defined, so this is obviously a typo. Yeah, so this whole thing I did very wrong. So it's good that I'm going through and fixing this. Oops, and I'm sure there's a much better way to do this, but for now, this will get the job done. So in my book, that's the most important thing, is to get the job done. There do exist favorite victories where the amount of energy and time you spend to be successful is so great that the success becomes dwarfed by the sacrifices you needed to make for the success. So overall, even though you were successful in that one endeavor, you were not successful. So that is a thing. I don't think it's a thing in this case. I guess what I could do is, I can use my... if I were to use hotkeys instead of the mouse, I could probably go a little faster. So using the arrow keys here. Yeah, this is what a expert level programmer would be able to do, is not use the mouse to click on that next. and not accidentally hit the wrong key on the keyboard and accidentally put that on another line. And not accidentally delete more than they were intending to. So yeah, it's a lot of work. Somebody who's better can do it faster by using hotkeys and not using their mouse to click this arrow every time. But this is welcome to software engineering. This is pretty much what you will see someone having to do. This is the down and the dirty. Okay, so that one's already fixed. Some of them are already fixed, so we're going to get 70 matches whether they're fixed or not. What we need to be matching on actually is pd.concat. Because that's... So now... Okay, so that looks better. We've only got 39 matches for that. And this is not only like software engineering. It might actually give away my background in network engineering, because this is what you'd have to do for configuration, unless you had a really robust like Ansible like configuration management automation system set up. But even then, you're gonna have to review it and make changes in it, possibly a lot of changes. It's work, you know. It's like software engineers actually get paid to do stuff. People who work from home actually get paid to do stuff. So this is the kind of stuff they have to do. This will take me a while. I'm sure there's a hotkey for finding the next. So what is the hotkey? What is the hotkey in VS Code for finding the next result in Control F? This will speed me up quite a bit. Wait, what?
In Visual Studio Code, VS Code, when you use Control plus F to open the Find widget, you can navigate through the search results using the following hotkeys. Find next result.
Okay, so Control F, enter that, and then Shift Enter to go to the prior one. So that will help a lot. But then maybe hit Control F again to get out of it. But then how do I get out of it? But then how do I get out of the Control F menu once I've found it, so that I can actually make the change without using my mouse? Oh, and it's not it's just freezing. Okay, well, that's too bad. Anyways, back to what I was doing. So the another thing to think about is always think about optimizations. That's really important. One thing I could do that would speed this up is revert my change where I added that function there, and revert it back to the where it was using dot append, because then I could just wholesale do a find all and replace all with dot append for dot concat, and that would resolve this issue in a matter of minutes rather than as long as it's taking me now, which is a pretty long time. But I've only got 16 left, so I'll just do it this way. Sometimes it's nice to have a little bit of brainless busy work. Makes you feel like you're really accomplishing something. And if it only saves you a few minutes to do it the right way versus the slow way like this, then either or is fine. But making a habit out of doing it the slow way is probably not good, because there's a point where you're just going to be behind. Okay, so now we've fixed everything. It should hopefully work. So I got to save the file manually, unfortunately, and then I need to probably do need to restart the kernel. I will run it. It's not going to give any information since they're not called. They're just defined. But there could be some issues where really truly messing this up make it so that they don't define properly. So yeah, that went through. Let's open the Jupyter Notebook again now. Go in there and get to that moment of truth. All right, so restart and clear output. Pandas looks good. Looks good. That looks good. That looks good. All right, and then the version should be 2.2.2. Looks great, and the moment of truth. Dang. What? Yes, it does. Okay, well, now it's getting weird. Okay, so this is a so we have to get a data frame object. So let's do so pandas dot data frame should be valid, and we need to spell pandas correctly. There. So this is a data frame object. We can see that in the dir right here. So let's see what we get with that. And again, do this beforehand before you spend all that time I spend. But there's a point where over the course of a 8-hour workday, you know, as long as you accomplish the thing, then you're fine. Let's see here. So, no, we don't have concat. Why did see? And this is why you can't rely on ChatGPT. It hallucinates. So it's probably add suffix, maybe. So let's just say you lied to me. It doesn't have a .concat. Oh, maybe from. Yeah, so we'll feed this in, but I kind of don't trust ChatGPT at this point. It gave me a lot of really bad answers. It's not trustworthy. They say that. Using it for work and stuff is kind of at your own peril. But we're going to say .concat and .concat isn't valid data frame method. How do I properly replace .append with something valid in version 2.2.2? Yeah, what the heck? Wait, PD.
You're correct that concat is not a method of the diaphragm class itself. Rather, it's a function in the pandas module.
Oh.
To replace append, you should use PD concat.
Wait, what?
Here's how you can properly replace append with PD concat in version 2.2.2. Example: replacing append with PD concat original code with append updated code with PD concat function for repeat use if you have multiple instances or want to encapsulate this behavior. You can create a helper function. Explanation: convert dictionaries to data frames. Before concatenation, convert each dictionary to a diaphragm. This is because PD concat requires data frames or series as input. Use PD concat concatenate the original diaphragm with the new diaphragm.
But
the ignore
no,
underscore
it's
index
not.
equals true
That's
argument
not.
ensures that the index is reset.
But no, that's not true. I mean, you can see. Oh wait, no, never mind. Hold on a second. Okay, so it should be here if I do dir pandas. Yeah, so it's there. So let's get a help on that. Okay, and then it takes an iterable, so you know that could be a list, and then you can have a data frame in it, and then another data frame to join it with. So now, can you pass it a dictionary as well? Because that would be nice. I don't know. We might need to do a method on the dictionary as well. Oh man, this is just too much for me. Yeah, I felt like we were fine with using that outdated version of pandas. So this is too much. I know how to do it now though, but we'd have to go through and make all those changes again. So I think you could do it like this. But where I'm not sure is I think you might have to do some sort of conversion method on that dictionary. So it would be like pd dot something, pd dot maybe like a to dictionary, or like there's also a merge that it'd be like to data frame. Something like that, or pd dot. So you might have to convert that. Yeah, this is just too much. Yeah, because we have to do this for all of them. And there are how many? There are 70 of them. So we have to do basically what I just did one more time. And we're not even guaranteed that the syntax is correct. Now, what we can do is verify the syntax. So let's do that quick. So if we do so we can do like, so we defined a data frame already. So let's do df equals pandas dot data frame. And then can we make it blank? We can. Okay, so help df. There we go. It's a data frame dir df. And it has, we can do the concat method on it. I think. Oh, no, we can't do the concat method on it. What? But okay, but we can do it this way. So df2 equals pandas dot data frame. Okay, and now we can do df combined equals pandas dot concat df1 df2, and then let's add that flag in there as well. Ignore index equals true. Df, okay, you're right, we didn't define it as df1. Let's define it as df1. Okay, so now we have 3 data frames. We have df, we have df1, and we have df2. You know what? We don't have df2. So let's get df2. I think we have df underscore 2. Yeah, let's get df2. Okay, so now we have df, we have df1, we have df2. So now let's try to make a df3 equals pandas dot concat df1 df2, and then the flag as well. Ignore index equals true. There we go. And now we have a df3, which is empty. Let's try to make one that's not empty. So we're gonna do a help on df. So it's a data frame. Let's do a help on pandas.dataframe. So we should be able to add so let's redefine df1. We'll say like hello. Okay, so the constructor is not properly called, so I don't know how to make pandas data frame. Okay, there we go. And now we can do df2 equals world. Okay, so now if we do df1, we've got like that. df2, we've got it like that. So now let's see what happens when we concat it. df3, there, hello world. So this we verified just now through this exercise will definitely work, so it might be worth it. This is really the difference between somebody advanced at coding and somebody not. It's not, are you using hotkeys? Are you doing things as fast as possible? It's, are you doing things that are actually valid? Because it doesn't matter how fast you can do the wrong thing. What matters is how fast you can do the right thing. And if you can do the right thing in an hour, whereas somebody can do a million wrong things in, half an hour, the person who does it right is the person who wins in the end. So, okay, so yeah, we're gonna do this. I'm kind of invested in it now, so let's see it all the way through. So let's go to instance number 1. All right, and now let's do it the right way. So the right way is we have to change this to PD. And then we have to put this in a list. All right, and now we have to do it 69 more times. And this is where carpal tunnel comes from, by the way. And you have to use the right characters too to make it even harder. And you have to get this menu to go away somehow. There we go. All right, not too bad. At least it's straightforward what I actually have to do now. So just time for the busy work. If you're like a senior engineer, you might even be able to get like a junior to do this once you actually know what the problem is. Or you just, yeah, so this is the kind of... I feel like this is the kind of thing like interns and juniors want to do as well. It's like they don't have to like really think about it that hard. They can just get in the code and actually do impactful things. And you can see it, basically what I'm trying to. It's all about thinking. Thinking is the bottleneck. I'm having a coherent thought, and that's how I'm able to accomplish this. Assuming I accomplish it, it could still not be. I could still not be on the right track here, but basically the thought is that the version of pandas is now different than when the book was written. Therefore, the methods used by pandas are not the same as they were when the author wrote the book. Therefore, so this is logical argument premises leading to a conclusion. So I should say the premises rather than therefore. So premise 1 is that the author wrote the book at a time when pandas was written with different methods. Premise 2 is I read the book and did the exercises at a time when the latest version of pandas moved on to use those updated new methods. So premise 3 is that updating the code so that it is compatible with the latest version of pandas may help the author and may help the author. Therefore, I am updating this code to help out the author and to make it so that I can use the latest version of pandas. Oh, okay, so now we're getting on to where I already fixed it. But I just fixed a random one in the middle, so we still got a lot of work to do. Oh, messed that one up. Oops. All right. So this is a time where it's good that I can multi-thread my thinking because I'm just zoning out here. This is time where you can put on a podcast or some music or something. This is kind of a little bit of every programmer's dream, to be honest. It's like you just have to do something like this. You don't have to think about. It's like the problem's already solved. You just have to make all the changes. And as I said, there's programmers that could make this change like really, really fast. But I am not one of them. We could use ChatGPT to figure out how to make this change more quickly, but for now, I've got 10 more. Oops, and I am getting a little bit of a headache. It's just from my headphones not being adjusted properly. All right, so that's the last one. Yeah, the work gets done when you just chip away at it slowly like that. So that's the most important thing, is that it gets done. So let's go and verify that we didn't miss any here. So we're on number 6 of 70. Looks good to me. Yep, everything looks good to me. Should jump out pretty clearly. I'm just staring right at it, so it should jump out if something is wrong. All right, so everything looks good. Let's just do. This is kind of superstitious. We know it's not calling the functions, so we really don't get any real information there. Let's get the real information. Let's open the Jupyter and try to run it from there. All right, and then it's use case 4. It's this one. It's pandas 2.2.2, so we're going to do restart and clear all output. And then we're going to do run again, and run another time. Now we get to kind of a moment of truth, because if it doesn't load in, then there's a problem. Okay, now here's the real moment of truth. Oh my god. Yep, this is what I thought. So, I mean, we're closer now because all we have to do is convert it to a data frame. um, so how can I convert a dict to a data frame in pandas?
To convert a dictionary to a DAV frame in pandas, you can use the PD DAV frame constructor. Here's how you come up.
Yeah, so PD dot data frame. Oh my god. What? It's using dot append. You can't use dot append. It's not. See, it's out of date too. When they make this change, it's like everything's out of date. So, auto power off. Why did that? Oh, because it's doing a countdown for a keep alive. Okay. Man. So, well, shoot. Well, let's be more specific. Let's say convert this dictionary this Python dictionary to a pandas data frame. Okay. Okay, so we can do that. Okay. All right. So that's all we gotta do is PD PD dot data frame like that. Yep, that's all we gotta do. Okay, might as well. I'm sure there's a better way to do it. Yeah, there's a better way to do it. Let's not do it like that. Let's do another line. We're gonna say tree df equals equals the conversion. So yep, and then place it down like that. Okay, so I like this. This will do it a lot better. So this we got to go through all 70 again now, but I think this will. And I knew this was going to be a problem. Just taking things one step at a time here. Okay, so we gotta change this to df now. Yep, and then df equals that. Inventory entry. All right. All right, that looks good. So yeah, we got to do that for all 70 now. And honestly, a way to make this faster is we can come here and do Windows paste, and now we get this equals and then Windows paste again. That'll make it a lot faster, and then we can copy this, and then if we see that this is the same, then we can just so that's the same. So all we need to do is put it in like that, and that'll make it a lot faster. Okay, now this one's different. It's policy entry. So we've got to use it different like this. And I think I made some mistakes there. I forgot to do DF. But we'll address the mistakes later. Let's just keep going. And let's go up to the other one. Okay, so this one is different. Good. This one is that's the same. That's the same. Okay. Now this one's not highlighting. I'm not sure why it's not highlighting. Oh, now it's highlighting. Okay, good. Just took it a while. I think the auto save. Okay, template entry. There we go. Oh, but this is where I'm gonna make a lot of mistakes, but that's okay. I'll go back over it. Oh, so now we got a different one here. So I paste it there and there. And this needs DF and DF. All right, very nearly done here. A lot of work that I just did. This video is probably going on pretty long. Okay, we got a new one here. You can see just how important the highlighting is. Without the highlighting, it's hard to catch mistakes. Okay, now this one is interesting because it's I'm not sure how easy it is to convert this to a yeah, because it's a list. So I'm not sure if you can convert a list to a data frame easily. Yeah, I'm not sure if this will work here, but this is what the answer would be if it works, but I don't know if it works. Oops. So now I can use windows like this, and there we go. Speeds things up pretty quick. Oops, and that's going to be a really bad error. Glad I caught that one. Using the wrong variable there, that would be very hard to catch. All right, so I think this is the last. Oh, you know what? It's not the. Yep, so we're back to 1. So I did make some mistakes here. I didn't put the DF down here for at least one of them, I'm sure. So let's go look back through my work, make sure I got this right. Yeah, so this one I'm missing it. This one as well. And this one. And this one. I missed it for quite a few of them. Okay, and now here's where I got it right. I should make sure I didn't accidentally swap those out as well. Everything looks right to me now. All right, so that's it, and I hope I'm really glad I was able to do this because this gives people a sense like where like software engineering, you're just sitting at home in your pajamas all day. You're not actually doing any work. You know, we can just saw for an hour and a half. You know, I was doing the kind of work that a software engineer will do every day, and it's hard work to we saw I had to redo my work 3 times because I was doing it incorrectly. And you can't rely on ChatGPT because ChatGPT doesn't always get it right. So, yeah, it's real work. It's not. Software engineers don't just sit around doing nothing all day. All right, so UC4, and then kernel, restart and clear all. All right. Version 2, there we go. And there we go. It's working. It didn't give me those errors right away. So I fixed it. I made it compatible with the latest version of Pandas. So big win for this channel. I will also go through the process of actually contributing it back to the original fork. So let's do git status. And I think I have it open in this one here. Well, let's just close these. Let's just do it in this one here, regardless if I have it somewhere else. Okay, so now we've got the staged file. So let's commit the staged file changes only. Let's review them first, make sure there's not anything I don't expect. So we're going to click on the comparison. Oh, it looks like I actually added a new space there. Let's take that out. We only want the actual changes. So because the file, I think we have to unstage it so that it's not in read only. Don't need the template anymore. Okay, so now it's not in read only. So I added a space here. I'll get rid of it. Everything else is the same. Yep, and then these are the real workhorse changes that are an actual valid contribution. And there's 70 of them. Oh, so we got a bit of a... Oh, no, that's the same. That's good. Okay, cool. Now, here there might have been a problem because we can see... Oh, no, this is right. This is right. Yeah, because it has to come from that one. Cool. Okay. Good. This is all looking great. Cool. Oh, okay, so just a few more down here. All right. Oh, so it looks like we got a bit of a problem here. So the behavior of data frame concatenation with empty or all NA entries is deprecated. Oh my god, everything's deprecated. You can't, no matter what you do, it's going to be deprecated. So to retain the old behavior, exclude the relevant entries before the concat operation. So this was line 1896, so this might have been the weird one. Let's take a look. No, this is the weird one. So this is the one that we have to do it like that. And that one, so everything else worked great. That's great, but behavior of data frame concatenation with empty or all NA values is deprecated. So let's see what ChatGPT can do for us here, because there might be a easier answer here. So
The warning you're encountering is due to a change in the behavior of PD, concat with empty or all non-entries. The warning suggests that in future versions, empty or all non columns will no longer be excluded when determining the result data types. To avoid this warning, you can exclude the relevant entries before performing the concatenation. Here's how you can modify your code to address the warning. Initialize the matrix underscore df data frame correctly by ensuring it doesn't include empty columns. Use a conditional check to handle empty or all null entries before concatenating. Modify code explanation check for empty list. If matrix underscore object underscore list or its first element is empty, return an empty data frame immediately to avoid further processing. Initialize matrix underscore df correctly. Use the keys from the first matrix object to initialize matrix underscore df with the correct columns. Conditional checks. Before converting matrix underscore object to a data frame and concatenating, check if matrix underscore object is not empty and if the resulting data frame is not empty.
Yeah.
This approach ensures that you avoid warning by handling empty or all null entries properly before the concatenation operation.
So I think we could just do this. Yeah, because then if it's empty, it won't do that. So let's try that. I don't know if I have to restart it or not. I just do it out of superstition, cargo culting, which is bad, but whatever. Came so close. The truth value of a data frame is ambiguous. Okay, so yeah, so we can't just do the if because it doesn't evaluate the true or false. So we can use we can use dot empty, you know, something like that. So let's use dot empty. Yep. So, and then let's test that here. So we have our data frame here, data frame 1. So let's do d1.empty. It should equal false. Okay. And then we'll say if not 1.empty print hello world. There we go. So it's going to print out because it is empty, so it evaluates the false. We can make it, or it is empty. Yeah, so it evaluates the false. And then not means you want it to evaluate to false to print it out. We could also do it this way, but then we wouldn't see the result because it evaluates to false here, and then we're not running the code if it evaluates the false. Here we are for this not operator, so we see it print out. So this is a valid way to do it. So let's do it that way. Okay, there we go. Good, looking good there. Looking good there. Looking good here. Looking good there. And kernel, restart and clear all outputs. There we go. Looking good there. Looking good there. Looking good there. Okay. Oh, and you know what? I might have needed to. I think I need the not keyword in there because what we, yeah. So it has to be if not, because if it's not empty, so this will evaluate to false. So then yeah. So I needed the not keyword there. Ah, shoot, I messed it up. It works, but it works bad because we want to do it. We want to. Yeah, it's bad. So this has to be a not because we're saying if it is empty, uh, then we're going to concat an empty data frame, which doesn't make sense. So we want to do this if it's not empty, then we concatenate a data frame that actually contains something. So let's try it again. Save the file. It's on autosave now, but it's a good thing to get in the habit of. Journal, restart and clear all. Okay. There we go. Okay, so it should get the same results now, but where we would see a difference is in the graphs. We would see that we'd get different results in the graphs, and the results would be would not match the book. And we might still see that. So really. So this is 1897, which I think is, yeah, so the same thing. So what is this? The behavior of data frame concatenation with empty or all NA. Okay, so even if it evaluates to false, so we must have gotten all NA entries. Yeah, so we must have gotten all NA entries. Okay, so is no longer empty or all NA to okay, so how can I? Okay, so I think I got this to work. And okay, so I think I got this to work by doing if not and then doing the dot empty. But the problem is if it has all NA entries, then it will not be empty. So what's a better method than dot empty, where I can tell whether or not it is actually empty, which I want to know, but also whether or not it's just only filled with the all NA entries, because I want to check for that too.
To handle both empty data frames and data frames filled with all non-entries, you can use a combination of mpn, dropnet, pi equals, all checks.
Okay.
Here's how you can modify your function to exclude data frames that are either empty or filled with all non-entries. Modified code explanation check for empty list. If metric underscore object underscore list or its first element is empty, return an empty data frame immediately to avoid further processing. Initialize matrix underscore df correctly. Use the keys from the first metric object to initialize matrix underscore df with the correct columns. Conditional checks. Metric underscore object underscore df. Empty checks if the data frame is completely empty. Metric underscore object underscore df. Dropnet pi equals alt empty checks if the data frame is filled with all non-entries by temporarily dropping rows where all elements are non and then checking if the result is empty.
Okay.
This approach ensures that you avoid adding data frames that are either empty or filled entirely with non-entries.
All right, I can try that. I'm way off in the weeds now. Okay, so we're gonna do this. If it's not empty, then we're gonna say okay. Okay, so that should do it. All right. Hopefully this works. Oh my, wow! I put way too much time and energy into this. But I wanted to. I just wanted to show what it looks like to actually work on code in a serious way on this channel. Outside of, just a tutorial or like something. Oh man, it again. Behavior of concatenation with empty URL. This is line 1898. But I'm not doing that. So what I'm saying is I'm not concatenating unless it's favorite attribute empty. Oh, okay. So I'm saying if it's not empty, and it's not empty when all of the NA things are dropped. So maybe what's happening is I'm getting a combination. I'm getting something where it's not empty when they're all dropped. So I'm getting a combination where there is some real values, or yeah. Well, no, it would be all. Include the relevant entries before the. Oh man. The behavior of concatenation with empty is deprecated. But the thing is, I'm not doing it. Okay, what? Okay, so we're converting it to a data frame. And then if the data frame is empty, so let's say df1 empty, that equals false, and we'll say dfm1 drop na equals all. Okay. T. Now there are none of those values there. So why this should work, right? This should work. Why is this not working? Yeah, but I dropped them all out. I only do it if it's not empty. Let's try it this way. Alright, this shouldn't make a difference, but maybe it does. I think I'll get the same error. Yeah, same error. So, man, this is bizarre. I mean, I just don't understand what the contents of my data frame are, and until I do that, like, I'll just never be able to resolve this issue. But hey, I made a lot of progress. The other ones are working, presumably. Okay, so this is more robust than that other one. So maybe that will do it. Okay, so let's try that. All right, so here we go. Hopefully that works now. It's just that method of detecting the value in the frame was not working. So I'm trying a different one. But really, I'm just blindly going off of what ChatGPT is telling me. Bad, bad, bad. What I need to do is actually understand the contents of the data frame and understand. Yeah. So obviously, what is happening here is the behavior of data frame concatenation with empty or all NA values is deprecated. So what's happening is when we do this object df is either empty or has all NA values. But where it gets tricky is, if it's not empty and it does not have all the values, only then are we going to concatenate it. So I don't know why it's maybe it's not matching on this one. Maybe there's another concat statement. No. Yeah, so and then it's calling out that line specifically. We can see that here, 1870, 1897. So yeah, the problem is that this metric df is either empty, oh, you know what? This is the problem. We have to use an or here because there are because yeah, we have to use an or there. Dang it. That is the problem, and I'll explain why later. Especially if it works. If it doesn't work, then that wasn't the problem. Anyway, I can explain my reasoning for it, but I'll keep it to if it actually works. We'll just see if it works here. All right, so I think this will work now because I really think the problem was the or, and I'll explain why if it works. Especially if it doesn't work, I can explain my reasoning for it, but it doesn't work. So, but I hopefully it will work. We'll see. Crossing my fingers. Doing a sound check in the meantime. Sound check passes. Nope, didn't work. So I guess what my reasoning was that in order for this to match, both of these had to be true, and or had to pass our check. So not empty. This would be true. Yeah, both have to be true. Not that it would be true. So, but if we were doing an and, then they would both have to evaluate to true. But if we're doing an or, one or the other has to evaluate to true. But the thing is, if it's all empty, then it's not going to be true that they're all. So you'll never have a situation where both are true because one is basically the opposite of the other. So, and I can demonstrate that here. I can say so df1 is df1.empty evaluates to false. So not df1.empty would evaluate to true, which is what we want. If it evaluates to true, then you run the code there. But now we can see if I do not that, and then I do and df1 dot empty without the keyword. Now it's going to evaluate to false. But if I do it with or, now it will evaluate to true because one of these is true. Otherwise, both of them have to be true. So, and it's not going to be the case that both are true, because if it's all NAs, then it's not going to be empty. So. Huh. You know what? I'd rather just do this in an else, because this not is just making it more confusing for me. So if it's empty, we're going to just continue in the for loop. Elif, so elif, it's not empty, but it only contains the not a number values. Then we're going to continue in the for loop. And then else, now we are going to do that concatenation, since we know now that these are true. That's just a much easier way for me to understand what the code is doing. The other way was just making it harder to understand. So I don't think this will fix the issue, but I think it's a better way to code this particular thing. Okay, and I actually forgot to clear and restart everything, so hopefully that doesn't make it. So I'll do it again if this fails. Even if it succeeds, I'll do it again with clear and restarting, because I forgot to do that. But I don't think it's gonna pass. It's just the way I wrote the code is the same. Yep, same thing. But let me try it again with the cleared, just because. Yeah, so obviously that wasn't going to change anything. It just makes it easier to think about the code. So if it's empty, then we don't want to do anything with it. We don't want to run this concat statement on it. Else, if it's not empty but it's all the NA, then again we don't want to do anything about it. So. Interesting. What if I take these out? I'm ready to move on from this. It's just it's a favorite victory at this point, where it's demanding more of me than I'm willing to give. It'd be nice to achieve it, but not at the expense of other things. And we could do a print statement as well. That should make things really a lot more clear. If we do a print statement here, that should show up in the notebook and make things clearer. Okay, so let's do a dot any. Yeah, like that. And now we got that print statement there, so that's the main thing to test, is to see if we can see what that looks like. Okay. Probably don't need to do that, but it's fine. Restart and clear all. Looks good, looks good. Okay, so there we go. So hopefully that print statement will be pretty eye-opening. It'll happen in a loop, so we'll see multiple entries for it. Probably look pretty kind of sloppy, but shouldn't be too bad to look at. Okay, so here's that print statement. So we'll still have the error at the end. Once it's finished, so we can see it's going through each. It's not at the end yet. Yeah, and now we can see. Oh, not quite yet. It's still working. Oh, what? Oh, that fixed it actually. Doing the any actually fixed it. Doing the any fixed it. Okay, well that's fine. So yeah, let's take this out. And yeah, I fixed it. Okay, well, hey, I think I did. We'll see if all the graphs are the same. So let's do a get status. Okay, and then let's stage this file. So we're gonna do get add sans.py. Okay, and then we're gonna stage this file to be ready for commit later. Yeah, so we're gonna delete this, and we'll run it one more time, and then we're going to keep following along with the book, and if everything looks the same by the end of this use case, we'll contribute this back to the author, and maybe get that merged in even, which would be cool. That would look really good for me. That would help everyone doing this book. They can just use the latest version of Pandas. You can get used to how that's meant to look. So set everyone else up for success to get used to doing things the modern way rather than with deprecated methods. And if it didn't work, then we'll see everything is quite a bit different down here in this metric data frame there. Oh, what the heck? Why was it? How come the printing got rid of this? 1901. The printing got rid of that. Well, all right. Well, let's just ignore it. Yeah, the printing got rid of that. It's fine, I think. So, yeah, that didn't show up when we printed. It probably just got overwritten or whatever by the print statement. But let's just go with what we got. I won't contribute this back to the author since it's not really completely solving all the issues. Yeah, it's still got a deprecated method. Um, so anyway, we got everything showing up fine. Everything's working just fine. So we updated the method for no reason. But it's time to move on for sure. So we are generating 29 days worth of data so we can observe the entire period of the growing trend before it is resetted, since SANS will reset the trend after that month period to start it again. As in the previous cases, you may simply load the data from an existing CSV file, bng underscore subscribers underscore metric underscore forecast.csv, or run SANS method. If you run the SANS method, you may not get exactly the same values as I will show you in the next sections, but there should be minor differences. It is just the random nature of the data generation. We get a data frame that looks like this. So that looks very similar to what mine looked like. Because we are going to use profit again, you will see in the notebook that we are creating two new columns, DS and Y, that profit will require. If we visualize our data, we can observe how it has all the ingredients we discussed above. And I'm not going to contribute my changes back to the author because just use the deprecated version, please. Just use the older version of Pandas. And I didn't even, I had to alter that one part of the code. I don't know if it's going to work the same way. So just don't bother, please. Don't. Yeah, so just ignore everything I did for the last 2 hours. Okay, so this is plt.title. Here's a big moment of truth. Let's see if it matches. Oh, so it looks like I accidentally ran this again. Let's just restart and clear all output. Make sure I'm running things properly. Okay, so BNG subscribers is where we're going to be at. Yep. Hopefully we get similar results there. It could be completely different with all the changes I made. Yep. I think it's because of that. Yep. So you know what we're gonna do? We're gonna undo everything I just did, because this is an example of software development in the real world. So this is what happens. And use an older version of the library. All right, so we're gonna destage everything, and we're going to revert all the changes. Because this is an example of coding in the real world. That's why. Okay, so and then we have to use the older version. So let's get rid of this. Yep, and then run it again. Okay. Open in browser and use the kernel clear all output. Okay, and then pandas 1.4.0. That's the one that's recent enough to not cause conflicts with other libraries, but old enough to still allow for that deprecated usage of appending to a data frame. So we should see the version 1.4.0. We do. So now this should run with just a warning for each entry. Each row and column in the data frame, there will be a warning. So we'll get a lot of warnings, but so we can see a warning for each line there. So we'll see a lot of warnings, but that's okay. The warnings don't matter. So let's run everything down to actually looking at the data frame, and the data frame should look like it does in the book. All right, so it looks like it's still working there, and we're still getting warnings, and the warnings are fine as long as we don't get an error. We don't have one, so yep, everything looks good. Still gotta just wait on it. All right, still working. So something about the warnings seem to make it run quite a bit slower, but as long as it's still running and it looks like it is, let's just leave it to cook. Alright, so this is actually kind of a problem. It's running way slower than it has ever run. If it takes 5-10 minutes to run every time, because you see how often I clear it out and run it again, that's just not going to work. So you can see how far along it is because it calls out the line number. But we got about 2,000 lines in this file, so we still got a long ways to go. So you know what I'm going to do? I'm going to pause it and be back. All right, I'm back. So it's been 3 hours. I'm getting distracted here. We see it did go through now. So it's working fine with that old version. But I'd have to run that again if I went back. Let's see if the graph prints out. Okay, so the graph prints out. It'd be nice if I could finish this whole use case, so I don't have to deal with running that again. Oh, and you know what? It looks like I can. Well, no, because the problem resolution section is really long. So, yeah, I think I've got to throw in the towel. So let's just read to the problem resolution, and that'll be the end of this video. You can identify there is a growing trend, more visible looking at the bottom line of the graph. There is clear seasonality, both daily and weekly, and there are a number of anomalies also visible which will also impact our analysis. We have introduced them because in reality, your data will also have anomalies. Therefore, the algorithms need to be able to deal with them as best as possible. So that's it for this mega 3-hour video of me doing work that I ended up deleting because it did not solve the problem. It just created new problems that I wasn't able to solve. So yeah, unfortunately, that's gonna be it. I'd like to get all the way through, but it's just too much for this one video. So thanks for watching, and see you in the next one.